Welcome to an exciting journey into the future of artificial intelligence. AI is everywhere around us today, from smart assistants like Siri and Alexa that respond to our voice commands to advanced self-driving cars navigating our streets. But have you ever wondered what's really happening behind the scenes of these incredible systems? The truth is, there are two fundamentally different approaches powering artificial intelligence. The first is symbolic AI. This uses rule-based reasoning, working with clear logic and if-then statements. Think of it as the methodical, structured approach. The second is machine learning. This relies on data-driven predictions, learning patterns from massive amounts of information. It's more intuitive and adaptive. But here's the exciting question. What if we could combine both approaches? What if we could harness the precision of rules and the adaptability of learning? That's exactly where hybrid AI comes in. And today, you're going to master everything about it, from beginner-friendly basics that anyone can understand, all the way to advanced real-world applications that are shaping our future right now. So let's dive in and explore the fascinating world of hybrid AI together. Foundations of AI. Before we dive into hybrid AI, let's make sure we understand the two foundational approaches that make it possible. First, let's talk about symbolic AI. Think of symbolic AI as rules, logic, and if-then statements. It's like having a comprehensive instruction manual for every situation. Here's a great analogy. Imagine a chess master who has studied every possible move, every strategy, every rule of the game. They approach each situation methodically, following established principles and proven techniques. That's symbolic AI, structured, logical, and rule-based. Now, on the other side, we have machine learning AI. This approach is all about data plus patterns plus prediction. Instead of following predetermined rules, it learns from experience. Think of it like a child learning to play games. They don't start with a rulebook. Instead, they play thousands of games, making mistakes, recognizing patterns, and gradually getting better through experience. That's machine learning, adaptive, pattern recognition-based, and continuously improving. Now, here's something important to consider, and I want you to really think about this. Exercise for you: think of one task you do every single day. Maybe it's driving to work, cooking dinner, or even just deciding what to wear. Would a rule-based approach work better for that task, or would a learning-based approach be more effective? Take a moment to really consider this, because understanding when to use rules versus when to use learning is at the heart of building effective AI systems. Most real-world problems actually benefit from both approaches, and that's exactly what we'll explore next. What is hybrid AI? So what exactly is hybrid AI? Simply put, hybrid AI combines rule-based symbolic reasoning with machine learning. It's not choosing between rules or learning, it's using both together to create something more powerful than either approach alone. Think of it like this: imagine you're building the ultimate problem-solving system. You take the reliability and explainability of rules and you combine it with the adaptability and pattern recognition power of machine learning. The result? A system that can both follow logical procedures and learn from new situations. Let me show you how this works in practice with two examples you encounter every day. First example: virtual assistants. When you talk to Siri or Alexa, what's really happening? The machine learning component is processing your voice, converting those sound waves into words, understanding your accent, and dealing with background noise. That's the learning part. But then, the symbolic reasoning component takes over. It applies logical rules to understand your intent, follows structured commands, and executes specific actions based on programmed logic. That's the rules part. Second example: healthcare systems. Modern medical AI uses machine learning to analyze symptoms, medical images, and patient data to predict potential diagnoses. It can spot patterns in thousands of cases that no human doctor could remember. But then symbolic reasoning applies established medical protocols, treatment guidelines, and safety rules to recommend appropriate treatments. It ensures that recommendations follow proven medical logic and safety standards. The magic happens when these two approaches work together seamlessly. Machine learning provides the insights, while symbolic reasoning ensures those insights are applied safely and logically. This combination gives us systems that are both smart and trustworthy, both adaptive and reliable. Why hybrid AI matters. Now you might be wondering, why is this hybrid approach so important? Why not just use machine learning for everything since it seems so powerful? Let me show you through two compelling real-world case studies. Case Study 1, IBM Watson in Healthcare. IBM Watson became famous for beating human champions at Jeopardy, but its real impact came in healthcare. Watson uses a hybrid approach for cancer treatment recommendations. Here's how it works. The machine learning component analyzes vast amounts of medical literature, patient records, and research data. It can process information from thousands of medical journals and millions of patient cases, far more than any human doctor could ever review. But the symbolic reasoning component applies established medical protocols, drug interaction rules, and treatment guidelines. It ensures that every recommendation follows proven medical logic and safety standards. The result, treatment recommendations that are both innovative, drawing from the latest research, and safe, following established medical wisdom. Case Study 2, Autonomous Vehicles. Self-driving cars are perhaps the most visible example of hybrid AI in action today. The machine learning component handles object detection and recognition. It identifies pedestrians, other cars, traffic signs, and road conditions in real time, even in situations it has never seen before. But the symbolic reasoning component applies traffic laws, safety protocols, and driving rules. It ensures the car always follows legal requirements and makes safe decisions, even when the machine learning component is uncertain. This hybrid approach gives us three crucial benefits. First, transparency. We can understand and explain why the system made specific decisions because the rule-based component provides clear logical reasoning. Second, accuracy. By combining pattern recognition with logical rules, we get better performance than either approach alone could achieve. Third, scalability. The system can handle both routine situations through rules and novel situations through learning, making it adaptable to real-world complexity. This is why major tech companies, healthcare organizations, and autonomous vehicle manufacturers are all investing heavily in hybrid AI approaches. Under the Hood Technical Deep Dive. Now let's look under the hood and understand the key technologies that make hybrid AI possible. There are three fundamental components you need to understand. First, knowledge graphs combined with deep learning. Knowledge graphs represent information as networks of connected facts. Think of it like Wikipedia, but structured so computers can understand relationships between concepts. Deep learning then uses these structured relationships to make more informed decisions. Second, explainable AI or XAI. This is crucial for hybrid systems because we need to understand not just what the system decided but why it made that decision. The symbolic component provides the logical reasoning, while the machine learning component provides the data-driven insights. Third, natural language understanding. This allows hybrid systems to process human language by combining pattern recognition for understanding meaning with rule-based grammar and logic for precise interpretation. Now let me show you a simple example of how this works in code. We start by importing a decision tree classifier from scikit-learn. We create training data with two features. These could represent any two characteristics we want to classify. We define our target classes, rule-based and learned, representing the two different approaches. We train our decision tree classifier with this data. Finally, we make a prediction on new data. When we run this code, it outputs learned, showing how the system combines machine learning classification with rule-based logic to make hybrid decisions. This simple example demonstrates the core principle. We're not just using machine learning or rules, we're using machine learning to inform rule-based decisions, creating a system that's both data-driven and logically structured. In production systems, this concept scales up to handle complex real-world problems with thousands of features and sophisticated reasoning chains. Building a mini hybrid AI project. Now it's time to get practical. Let's walk through building a real hybrid AI project together. We're going to create a hybrid chatbot that combines the best of both worlds. Here's how our hybrid architecture works. The machine learning component handles intent detection. When a user sends a message, our ML model analyzes the text and predicts what the user is trying to accomplish. Is they asking for help, making a complaint, requesting information? The rule-based component handles conversation flow and fallback responses. It applies logical rules for how conversations should proceed and provides structured answers when the ML component isn't confident. Let me show you the code structure. Our main function takes user input and first uses the ML model to predict intent and calculate confidence. Here's the hybrid decision logic. If the confidence score is below 0.7, meaning our machine learning model isn't very sure, we fall back to rule-based responses. These are predetermined, reliable answers for common situations. But if the confidence is high, above 0.7, we use the ML-based response, which can be more dynamic and contextual. This hybrid approach gives us the best of both worlds: reliable, consistent responses when needed and intelligent, adaptive responses when we're confident in our predictions. Here's your practical exercise. Try modifying the confidence threshold. What happens if you make it stricter, like 0.8? The system becomes more conservative, relying more on rules. What if you make it more liberal, like 0.6? The system becomes more adventurous, trusting the machine learning more often. You can also experiment with retraining the ML model with different examples, or adding new rule-based responses for edge cases. This type of experimentation is exactly how you develop intuition for when to trust learning versus when to rely on rules, a crucial skill for building effective hybrid AI systems. Advanced applications. Now let's explore how hybrid AI is transforming entire industries with advanced applications. In finance, hybrid AI is revolutionizing fraud detection. Machine learning components analyze spending patterns, transaction timing, and behavioral data to identify suspicious activities. They can spot subtle patterns that traditional rule-based systems would miss. But the symbolic reasoning component ensures compliance with financial regulations, applies risk assessment rules, and makes decisions that can be audited and explained to regulators. In robotics, we're seeing incredible advances in autonomous navigation. Machine learning enables robots to perceive and understand complex, dynamic environments, recognizing objects, predicting movements, and adapting to unexpected situations. Meanwhile, symbolic reasoning ensures robots follow safety protocols, respect operational boundaries, and make decisions that align with their programmed objectives. In smart cities, hybrid AI is optimizing everything from traffic flow to energy distribution. Machine learning analyzes real-time data from thousands of sensors to predict traffic patterns, energy demand, and resource needs. But symbolic reasoning applies city planning rules, safety regulations, and policy constraints to ensure optimizations serve the public good. Let me share a detailed case study that brings all this together: Tesla's Autopilot system. Tesla's approach perfectly demonstrates hybrid AI in action. The machine learning component handles computer vision and scene understanding. Multiple neural networks process camera feeds, radar, and ultrasonic sensors to create a detailed understanding of the driving environment. They identify vehicles, pedestrians, road markings, traffic signs, and even predict the behavior of other drivers. The symbolic rules component applies traffic laws, safety protocols, and emergency procedures. It ensures the vehicle always follows legal requirements, stopping at red lights, yielding right-of-way, maintaining safe following distances. But here's what makes it truly hybrid: these systems work together continuously. The machine learning identifies what's happening in the environment, while the symbolic reasoning decides what actions are appropriate given traffic laws and safety requirements. The result is a system that can handle novel driving situations through learning, while maintaining absolute adherence to safety and legal requirements through rules. This is the future of AI systems that are both intelligent and trustworthy, both adaptive and reliable. Challenges future in your final project. As we near the end of our journey, let's be honest about the challenges we face with hybrid AI. And then I'll give you an exciting final project to work on. Current challenges include Complexity: integrating multiple AI systems is genuinely difficult. You need expertise in both machine learning and symbolic reasoning, plus the engineering skills to make them work together seamlessly. Cost: hybrid systems require more computational resources and development time. You're essentially building and maintaining two different types of AI systems. Explainability: while hybrid systems are more explainable than pure machine learning, making the interaction between learning and reasoning components truly transparent remains challenging. But despite these challenges, the future is incredibly exciting. We're moving toward AI systems with common sense reasoning, artificial intelligence that doesn't just process data or follow rules, but actually understands context, applies wisdom, and makes nuanced decisions the way humans do. Now here's your final project challenge. Build a hybrid AI spam filter. Here's what you'll create: a system that uses machine learning to detect spam patterns in email messages. Train it on examples of spam and legitimate emails so it can recognize subtle patterns in language, sender behavior, and content structure. Then add symbolic rules for filtering by specific keywords, sender domains, and message characteristics. Create rules for obvious spam indicators like suspicious links, excessive capitalization, or known fraudulent domains. The magic happens when you combine both approaches for maximum accuracy. Your ML component catches sophisticated spam that follows new patterns, while your rules component catches obvious spam and prevents false positives. This project will give you hands-on experience with the core principles we've covered throughout this course. Let's wrap up with your key takeaways. First, AI has two main branches: symbolic reasoning and machine learning. Each has strengths and weaknesses. Second, hybrid AI combines the best of both worlds, creating systems that are both intelligent and trustworthy. Third, real-world impact is already happening in healthcare, autonomous vehicles, finance, and countless other fields. Fourth, the future belongs to more explainable, trustworthy AI systems that can reason about their decisions. Now here's your call to action. Take what you've learned about hybrid AI and apply it to your own projects. Start small, maybe enhance an existing system with some rule-based logic or add machine learning components to a rule-based system you already have. Share your results, your challenges, and your discoveries in the comments. The AI community learns best when we learn together. Remember, you're not just learning about technology, you're learning to build the future. Hybrid AI represents a path toward artificial intelligence that's not just powerful but trustworthy, explainable, and aligned with human values. Start building the future of AI today. Thank you for joining me on this exciting journey into hybrid AI. Now go out there and create something amazing. Fuel the algorithm, hit like, thumbs up, share rocket, and subscribe bell for more AI power. Join the hybrid AI journey, like, share, and subscribe for smarter updates.